let's start talking about making an entity system. We've looked at the sample code we have with the sprite manager here that works with a shared resource where we will initialize a massive list. Each sprite in turn has a reference count. We make sure that if we've already loaded one, we're not going to load the same copy of the same sprite. We'll just give a reference, or rather a pointer, to one we've already loaded and increase the reference count. Entities are a singleton system, which means that each entity is unique. So we're not going to be doing the reference count. We're going to be doing the in-use flag. The reason we're doing this is because, as with most video games, we're going to be designing a system to preload everything. Whenever we're doing any kind of file operations, whether they're asking to load up a file from disk, asking for memory, anytime we have to interact with the operating system, that is going to be time wasted if we can do it ahead of time. In fact, the old guideline for computing is don't compute, pre-compute. If you can possibly do work ahead of time, do that work ahead of time. Which is why, if you've ever played a video game in the last 40 years, you will see most video games after hard consoles have a loading time when we have to load up all the assets, allocate all the memory, do all the work ahead of time for a level as we load it, and then we go on to the next level, and then we have to then throw out all the old data and load up all the new data. So we're going to be doing that same kind of thing now with our entity system. We are going to pre-allocate all the entities that can ever be, or ever will be, active at the same time in our system. So, to begin, let's make a new file new. I am going to make a header file first, so we're going to start with a compiler guard. And before we do that, we actually do the pound if not defined entity.h, define entity.h, and then end if. If you spell it correctly, that'd be great. We're going to call this thing our entity system. If you want to do the commenting to give us ourselves a purpose here. Actually, let me save this as, right there. I'm going to save this as entity.h. If I were making this as a generic system for the library, I would probably prefix it with gf2d. If you know what the name of your game is going to be and you've decided on a prefix for your game, you can go ahead and put that. But since I'm just using this as a class example, let's throw away. I'm just going to forego any prefix and just call this entity.h. Now that I know it's a header file, I have context awareness. We could add a purpose if you would like to describe, what's the point of this file. We are going to define a new data type. So we're going to type def struct. Oh, no autocomplete for that. Thank you. And we're going to define this as an entity. Again, if you have any kind of a prefix like that you want to add, go right ahead. I'm not going to at this point. I'm also going to pre-name this entity struct. This way, if I need to declare a reference to the entity within the entity type, before the entity type has been defined, I can. This is like how they did it in ye olde Quake 2. First thing I want is a flag to determine if this is in use or not. So I'm going to make a uint8 underscore in use. By prefixing a variable or member variable with underscore, this is a C convention to say, hey, treat this as a private variable, even though we don't have private variables technically. So don't touch anything that starts with an underscore. It's still valid syntax, but we're not going to use that. Now, I'm accessing uint8. Uint8 is actually defined either in SDL or as a pass-through through my types. So I'm going to need to include what a uint8 is. Now I'm using quotes here because I'm going to include my GFC types.h. Now, if you are very unlikely to see this change during the course of your project this semester, so feel free to actually just do the hard brackets. But, went too far. I'm going to go ahead and use the quotes. And remember, the order of includes is least volatile to most volatile. Now we're going to start defining some things that our entity is going to need. To begin with, I'm probably not going to need anything more than a sprite. So I'm going to include sprite.h, and I'm going to declare something as a type of sprite. So, and that is more volatile than GFC. This is GF2D sprite.h. And now I can do a sprite. Let's call it the sprite. And if you want, we can do some commenting here. This is the way to do an inline commenting on what a data structure element is. So I can say this is the there we are. And the entities graphic, if it has one. Actually, that's an interesting point. If it has one. I don't want a sprite. I want a pointer to a sprite. All the sprites are managed by the sprite system. So I'm not going to keep a copy of the sprite structure. I'm going to keep a pointer to the sprite structure. I'm now going to need to know where on the screen I'm going to draw this thing. So I'm going to need a vector 2D. It's a 2D game. And I'm going to call this position. I like to keep it vertically aligned. It's still a habit I picked up from one of the previous places I used to work. Where on the screen to draw the thing? And for now, that's not going to be enough. We're making an entity. Entities have behavior. The way we get behavior is by defining think functions and update functions. And the cool thing with C is that we can do that same kind of thing we would do through virtual functions in C++, but with function pointers. And I always remember the syntax poorly, but if I remember correctly, we go with the type that it's going to return. So what I want to do is make a think function. So I'm going to do void. The name of it is going to be think star or star think. I think it's think star. And then the parameter list. Because C has no class system, there's no automatic assumed this, we need to pass the thing that we're going to be modifying with all of our functions when we're making a class-like structure. So I need a pointer to an entity, which hasn't been defined yet at line 16. So I'm going to use the struct entity S as a forward declaration type, and we're just going to pass it ourselves. I'm probably going to need an other function too, which is going to be the, what do we call it here, an update function. Note on think and update. If you remember from Quake 2 modding, they only showed us the think function and then it had a global update function we probably never even saw the likes of. The idea behind having a separate thing, now you might think they're the same thing, like it gets called periodically or once a frame to do the things that are needful for whatever the entity requires. But with the order of how it appears in memory, what you're going to see later is we iterate through this in order of memory. If we did the updates and thinks at the same time, that means that the first entity in the list is going to be operating on old information, and the last entity in the list is going to be basing its decision-making based on the most up-to-date state of the world, or at least the state of the other entities. So to make things fair, we're going to do one pass to think, where we make decisions based on the world state, and then one pass to update, where we will then change the state based on what we decided to do in the think function. So that's the differentiation between think and update. So here, this is going to be function to call to make decisions. Function to call to execute those decisions. All right. It is also very likely we're going to need at some point a free function. So we're going to call this one free. And the point of the free function is to clean up any custom allocated data. And to have that allocated data, we're going to add a void pointer. Data. This is going to be for ad hoc additional data for the entity. The idea is that a player might have some additional information that the rest of the entity types do not have. Monsters are going to have some other data that the rest of the world doesn't have. Items are going to have different data to have associated. Unless we need it common for all entities, it shouldn't necessarily live in the entity common structure here. This is like how in Quake 2, again, I'm going to reference that all the time because we're using that as the template here, would have the pointer to item information, the pointer to monster information, and the pointer to client information, because not necessarily every entity would have item or monster or client information. Here I'm just using one-stop shopping and just calling it the data pointer. Whatever that needs to be will be cleaned up by this function here. If we don't have custom data, then we can just leave this as null and we won't actually do anything with it. From here, this is probably enough to move on. Remember, if we're defining a resource manager, we need to have some core resource management functions. So we're going to need a void entity system initialize. And maybe we'll take a uint32 type that's going to be how many, no, let's spell that correctly. uint32, no, spell that correctly. Max, however many entities we're going to have as a possible max. Now, whenever we're forward declaring a function, it's good habit to then give us a brief about what we're going to do here. So this initializes, we're going to write it in present tense, not future tense. This initializes the entity management system and queues up cleanup on exit. And what the parameter does, the maximum, the number of entities that can exist at the same time. Now remember, whenever an entity is, killed or no longer needs to exist, we're going to free it up its memory slot so we can reuse it. But let's say we're going to set this to, like, say 1,000, or if you're making like a bullet hell kind of game, maybe 8,000, something absurd. Or if you're doing a smaller style game, that might be 16. Depending on how many entities your system is going to need, you don't need to over allocate. Another function that we're going to need, again, once we initialize the system, it'll be freed up. We're probably going to need an entity clear all. And what this is going to do is probably be used between levels to clean up all active entities. And you know what? We're probably going to need an entity that we don't want cleared up. So I'm going to take entity star here, and we're going to add an ignore at param ignore skip. Do not clean up the entity. Do not clean up this entity. All right. So now this is the entity system. We're then going to need to actually create the resource. So we're going to take entity star, entity new. And what this is going to do, at brief, get a blank entity for use. At return. Now what happens if we've allocated 1,000 entities and we're asking for the 1,000th first? Well, it'll return null on no more room or error. A blank entity otherwise. And now we're going to do entity free. Void entity free. Yep, scan. And this is going to take a pointer to an entity. I like using self as the term. The thing that's going to be doing the work on. At brief. All right. clean up an entity and free its spot for future use. At param self the entity to free. All right, so we create, we destroy. We create, we destroy. Now we're going to need the utilization of said entities. So we're going to need to be able to, as a resource manager, utilize the entity. Now, what does utilization mean for an entity? Well, it means updating its position. So we're going to do void entity system think. And what this is going to do, run the think functions for all active entities. And if we think, then we're going to update. And finally, draw. Run the update functions for all the entities, and then we're going to draw all active entities. So we can see it on the screen, and we can update its state, and it can all do the things. All right, now let's jump and make a new file. I'm going to include entity.h. It is no longer required, but I like tradition. I like to add an end line at the end of file. I like it also as a nice little bookmark or bookend for the file. It's not necessary at all, but I'm OCD. What can I say? I'm also going to, at this point, going to include simple logger.h because we're going to be following a proper best practice here of when anything can go wrong, we're going to log what went wrong so that we can debug this in the future. Sometimes just crashing isn't enough. Sometimes a debugger isn't enough. And sometimes going into that stuff is more work than we need to figure out what's going on. So now let us start. Oh, yes, save the file. This is going to be a source file. And this is going to be entity.c. And we're going to make all these functions. So copy pasta. Low on carbs. All right. So let's initialize the system. Before we do that, we're going to need the entity manager system. So the entity the world needs to know about, that's why that goes in the header file. The entity manager itself doesn't necessarily need to be known by the world and probably shouldn't be. So we're going to make a new type def struct here. And this is going to be the entity manager. And what we need to have here is an entity star entity list. And then a uint32 entity max, which is going to be that number right there. And if we need any other common config for the system, we can think about expanding that here. But this is now like just the simplest model that we're going to go with. So the entity system initializing. So we need to first do some sanity checking. We can't allocate 0 entities, so we're going to check to see if not max. Then we're going to slog, the simple logger, cannot allocate 0 entities. Cool thing about slogs, it automatically adds the end of line character to the string and provides us file and line number for where the error message was slogged from. We're now going to return. We are going to need another function here at some point. We're going to need the void entity, entity system close. And this is going to be a void function. You can either forward declare it here, or we can just do it. For now, I'm just going to forward declare it because we're going to see what this looks like. Now we're going to need an entity manager. I declared the type, but we don't actually have one. So what I'm going to do is I'm going to make this a global. Gasp! I know, global variables. Aren't those illegal? Only by people who don't know how they're supposed to be used. This is going to be a static variable. We're going to make an entity manager, and we're going to call it entity. Maybe we'll make it underscore entity manager equals 0. This is going to syntax already. I just did it. It's in muscle memory. It is star star open bracket, star star open bracket, close bracket. Initialize a local global file entity manager. Now, this static keyword here is going to make sure that even if someone knows this variable exists and they try to extern it or access it from another C file, it will not be allowed. Like even trying to do something will cause an error during compilation. This is just a sanity check that we don't try to step where we shouldn't step. This is how we get private variables in C functionally. All right, now we're going to need to actually allocate the system. So we have the entity manager. It's been initialized when the program launches to be 0. That's what that 0 in the brackets does. This is just making sure that this pointer is a 0 and this number is a 0. The entity manager now we need to allocate all the things we're going to allocate. And as I mentioned during the previous video with looking at the sprites, I get tired of writing the same boilerplate code all the time, so I made a little helper function to handle the sanity checking the variable, the inputs, and make sure that we're not trying to make something of 0 size, which would cause a segmentation fault. It checks to see that we actually got something back, so we didn't run out of memory. So we validate that. And then we set the whole thing to be zeroed out, which is not default behavior for many things in C. All that fun stuff I put in types, and it's right here, GFC allocate array. It returns a void pointer, a pointer to the data that we're allocating. And we're going to set that here. The size of the thing that we're going to do is going to be size of, which looks like a function. It's not a function. How many entities we want? We want max. So just a note on this. The size of is executed when we hit compile. And what it does is it looks at either the data type or the variable that's here. So we can even provide variables in size of. And it returns the size of in bytes of whatever it is there. So like however many bytes this ends up being, this will return that. And then the data type that it uses is size t, the standard C size variable. Let's just double check that we got one. Oh, by the way, this is entity manager dot entity list. All right. Now, if this is not, we are going to return. In theory, we should already error out why it failed, but if we want to be even more specific, and then we'll have a couple of different error messages here. We can slog out what happened here. We can say why that failed. This is failed to allocate global entity list. All right, so we now also need to make sure that our max is set. So we're going to, okay, I still have it there. Entity max equals max. All right, now that we have successfully initialized the system, we are going to queue up the cleanup. So at exit, we're going to call entity system close, which I haven't defined yet. So I need to make sure I define that next. So again, whatever I create, I'm going to destroy. So I'm going to leave myself a little comment here because we're going to probably call clear all in this. So we're going to call clear all, ignoring nothing. And then we are going to call free on entity list. And then we're going to memset, just in case someone closes this prematurely, we're going to memset entity manager 0. How much we're going to memset? Size of the type. Which, well, as I said, it doesn't necessarily have to be the type. It can be the variable itself. So basically, we're going to just set both these. And if I ever add anything else in the future I want to be zeroed out, it'll automatically zero that out. This last step should be unnecessary if it's only called at the end of life, but you never know. In fact, if you want to make another argument, the entity system itself should be a singleton. So before we even try to do anything, we can check to see if this pointer exists. If we have this, then we should slog. So I say I try to accidentally call this twice. Cannot have two instances of an entity manager. One is already active. Return. So just make sure we never actually have, oh, and that's if null. This is if not null. In fact, we should even do this sanity check here. We can't free something if this is null. And free doesn't error check. This will actually error out. So we should sanity check if. If we have a list, free the list. Because what if someone tries to call this before we've initialized this whole system? Then we're going to have a seg fault. All right. So this keeping our system clean. All right, clear all. So this is where we would now need to clean up and free up anything that we may have allocated for our system. So I'm going to show you this design pattern next, which is going to be a for loop. We need another counting variable. I like I. Everyone likes I. And we're going to go for I equals 0, while I is less than entity manager, entity max, I++. Now, if this sub I, what we're actually going to do, I'm going to ask the negative question, if this not, so if we don't have a entity here, actually this is going to be dot in use, which is underscore in use. So if this memory slot is not in use, continue, which is basically skip this iteration of the loop. I find it better to find ways to reject when I'm in a loop so I don't end up having 15 layers of blocks, of scope blocks. All right, so now let's take a look at our data type here. It's simple, so but let's see what we may have allocated for the entity here. So I'm seeing one pointer here. That's a good hint that we have something allocated, the sprite pointer and the data pointer. So first thing I'm going to do is get rid of the sprite. So let's take a look at the sprite code and look for a sprite cleanup function. Oh, look, it's called sprite free. And this will clean up the sprite for that. Notice I'm using the dot operator because what's going on here is the entity list itself is a pointer to an entity, but we allocated a whole lot of them contiguously. So this is a pointer. Pointers and arrays kind of functionally operate the same way. When I declare something as an array, I basically allocate a whole bunch of memory, and then the variable itself just gives me the memory address where that starts. And then when I index into it, like so, what I'm doing is I'm offsetting from the memory address stored here. I want to move this many units in offset from that memory location, which is why we start with 0. The offset is 0 because it's stored at the point where we're looking. But then 1, it will be one entity's size down the road, and then 2 will be 2 entity sizes down the road, and so on and so forth until we've hit entity max. But since I'm indexing into it, I'm no longer accessing it as a pointer. I'm actually accessing it as the data. It has been dereferenced. It is the data. Now I need to check to see if this, which should be my copy buffer still, has a free function. Now, it's a function pointer. It is a variable, so I'm checking to see if we have a memory address associated with this, if it's not null. If we have it, we're then going to call it. Now we have the parameters, and we need to give it the data to free. Now it'll do the work. And yeah, that's how you would clear up all of the entities. This will, oh, except for one other thing. If it's in use, we skip. If the memory address of this, so here is the variable, but if I want the memory address of the variable, I need to reference it with the ampersand. So if the memory address of this equals our ignore, skip it. There. Now, in theory, we can call this at the end of a level to clear a level we have out and not free up the player. Of course, this only works if it's a single player game and there are no additional entities that we would need. But that's a use case that sometimes is handy. All right, now let's actually create a new. Notice I'm deleting these comments along the way. I don't need these comments in the C file. The header file is the table of contents for this. So entity new, it's going to look a lot like this. We are going to, for I equals 0, while I is less than entity manager entity max, and we're going to check to see if we have something in use. Only this time I'm asking to see if it is in use. Skip any active entities. And now, if it's in use, we should start initializing, and we should do any kind of boilerplate updates here, so that if every entity needs something set ahead of time, this is where it would be set. So I'm going to memset the address of this index to 0, size of an entity. I'm going to set its in use to 1. So that's some boilerplate code for accounting. I need to make sure that we're not going to reassign it so that whoever asks for a new entity doesn't have to remember to set it. Some other things that are good to remember to just automatically do is setting the default color. Because if the default color has an alpha channel of 0, it's going to be transparent. You're not going to see it. Setting the default scale, because if I scale something to 0, it goes away. We have some technical difficulties there. And maybe anything else that you would need to make sure that your game has set. I don't have any of those variables in here yet, so I'm just going to leave this alone. I'm then going to return, once again, a pointer to this memory address. Now, if I go through this entire list and I find that all of my entities are in use, I'm going to return null. Now, I'm not setting this as a necessarily... No, I'm going to set this as an error condition. So we're going to slog this and say no more available entities. And that's why we're returning null. So this will show up now in our log. So if you're all of a sudden playing your game and you're testing it and nothing is happening, nothing is spawning, maybe you'll look at the log and see a whole bunch of this message saying, oh no, we were out of entities. You need to increase your entity count, or very likely you have a memory leak where you're not cleaning them up properly. All right, what we've created, we must also now destroy. And this is going to look remarkably like, well, this. So we're going to call, screw it, what I'm going to do, pardon my language. First thing I'm doing is, whenever we get a pointer that we need to do work on, we never trust it. So the first thing we're doing is sanity checking. So if not self, return. Can't do work on nothing. We're then going to free, and now right here, so this was the actual data. This is the pointer to the data, so we use the pointer operator to access its member here. That's the difference between here and there. And now, if self has a free function, then we're going to call self's free function on self's data. In fact, why have duplicate code? I can just call entity free in my clear function. Oh, I deleted it. Oh, good thing I did. Because now I'm just going to free the thing. Only what I'm doing is I'm going to free, I'm going to pass it the memory address of that. All right, so, and then anything else we allocate for our entity would get cleaned up here. All right, now the think function, or the system think, is going to look remarkably like the global system-wide systems. We're going system-wide functions here. So we're going to iterate through the entire thing and skip anything that is not in use. And here, let's make sure we're asking the question in the right direction. So this is where anything that is not in use gets skipped. Now, because the system, I may want to call an entity think specifically outside of this main system loop, I'm going to make a void entity think and have it take a pointer to itself. And this is going to be if not self return any boilerplate think stuff here. And then if we have a think function, then we are going to call our think function, providing ourselves as the pointer to it. And so this then calls entity think. And once again, we give it the one we're working on, but we're not taking a copy of the entity, we're taking the address of that entity, taking a pointer to that entity. And now let's go to update. Oh, look, it's going to be pretty much identical to this. It is literally the exact same thing, only with the word update. So we're going to just change the word think to the word update here, 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 and here. That was easy. And now entity draw is going to start similarly, but it's going to be a bit different. Start with our loop and skipping things that don't exist. Only when we have it, we now need to do the draw. In fact, once again, just to clean up the code from the work and the iterating through the work, I'm going to make it a draw function, which might need to be called sometimes additionally. So this is going to take the pointer to the thing that we're going to be doing the drawing of. If not self, return if self sprite. Now we need to draw the sprite. So let me go to the sprite header and take this draw function, draw sprite to the screen, draw sprite to the screen with all options. There's a difference here. Oh, this has clipping. This one doesn't have clipping. Yeah, let's do the big one. If I remember correctly, this just calls this with some of the variables defaulted. So let's do the big one here. We're going to default a lot of the variables that we're going to be using for now anyway. So we're going to render the sprite. What sprite are we going to render? Self sprite. At what position are we going to draw it at? Self position. At what scale? I don't have a scale yet, so I'm just going to null this out. These are functionally the center of scaling. If we're going to have a rotation, we're not. If we're going to have a flip, so horizontal or vertical flip, we're not. If we're going to have a color mod applied to this, we're not. And if we're going to clip the sprite in any way, shape, or form, we're not. Now frame. Frame is one that we probably should have. If we're going to have an animated sprite, we should have a frame to access. So I'm going to make this and add it to my entity H. Put next to the sprite there. The current frame of animation for the sprite. And I'm going to actually save this as a float. Although I can only render to an integer, I can keep track of frame rates. So I'm going to keep this as a float and then just cast it as an integer here. So we're going to cast it like so. And this is going to be self frame is where that's coming from. And now this is going to just call entity draw. Only not self. It's going to be this. Copy, paste. All right, before we do any other work, save everything. Let's compile it and see what kind of typos we have. Make. Oh, good. Plenty of typos to address. Let's start going through them. When debugging, always go to the top of the list, because sometimes a typo at the beginning of a file can cascade to millions of bugs down the file. So you're like, I changed one letter. How come there's 1,000 errors? Because there is one error. It's just causing a chain reaction. It's a domino. Like you knocked the first one down, everything else fell down. If we fix the first one, we fix the rest of them. And that's what I always forget. I always forget where the asterisk goes to make a function pointer. It goes first. So we're just going to delete, 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 star, 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 save it, try that again. Oh, look, it cleaned up most of my bugs. Entity manager, it needs a pointer, not the thing. So in entity.c, what we had here, so this is not a pointer. This is a variable. It's the global variable. It's set right there. It has a memory address in the code stack. So this function, what line was that? Line 41. Always make sure you have line numbers displayed. This memset entity manager needs the address of this, since this takes a pointer to set. Let's try it now. All right, now line 138. 138, it's this one. It needs, once again, it needs the pointer to that address. So like this is a pointer, then this dereferences that pointer to a specific spot in memory. Now this is the variable, but then we need the address to that one. And look at that, no more errors or warnings. I have suppressed the warnings that you get from converting from like float to int. I know, I don't care. If I'm doing it for a game, I'm usually losing precision and it's fine. I can now run this and nothing will change because I'm not actually calling any of my code. And I actually do want to get rid of that rendering output. Let's turn that off. Now let's actually start using the code. In order to use this code here, all I now need to do is tell this file that that exists. So we are now going to include entity.h. Now this is where dependencies of your systems will come into play. My entity system uses sprite. So I can't initialize my entity system before my sprite system has been initialized. So when I call my entity system initialize, I need to make sure it's after the sprite. And how many do I want? I'll take 1024. I'm not going to need more than a few, but whatever. Memory's cheap these days. I'm now going to need to also run my update functions. So let's go and take a look at entity system think. We're going to call this in our main game loop during our update section. So after we have updated our inputs so that we can check for input, before we start doing the drawing, I'm going to call entity system think. And then after I call entity system think, we're going to call entity system update, so that they all make decisions and now they all can do whatever it is they need to do. Let's go one step further and now draw the thing. So draw order matters in 2D. It is a lot like an episode of South Park made with cardboard. First season only. They moved to computer graphics after the first season. So that the thing we want as the background needs to be drawn first, and the things that we want in the UI, the mouse, should always be drawn last. So here is where I'm drawing the background, and then UI elements last, the mouse. So I want my entities to exist somewhere between the background and the mouse. So that's where I'm going to call entity system draw. Is that what I called it? Yes, that's what I called it here. Save. And now, let's make sure that the code, although that doesn't really have much to do, should hopefully not crash. Hey, nothing's crashing yet. Now, let us make an entity. We have the system in place. We now need to make specific types of entities. So I'm going to go ahead and make a new file. New. Pound if and def. We're going to make a player of some type. And we're going to pound define player. And then we need the end if to round out our include guards. And now I'm going to save it, make sure I'm in the include folder. Good. And this is going to be player.h. The player guards, as a convention, should always be named after the file itself with underscores instead of anything else. But honestly, as long as it's a unique identifier, you should be good to go. So we're going to need to make an entity star player new. And in order to use an entity, we need to include the entity system. So include entity.h. Cool. Now let's code this. Control new. Pound include. First I want my simple logger.h. And then I'm going to want to include player.h. And then everything else should go between these two. Because by the very nature of this is the work for this header file. This is the file for this. This is the header file for the source file. This is going to be the most volatile to this file, usually. End of line at end of file. It's kind of like my signature. It used to be the engine of lies, or the engineer of lies at the end of the file. Now it's just this. And let's save and put this in the source folder. And this is going to be player.c. All right. Now, in order to make the player work, we're going to need to forward declare a couple things. We're going to need... Uh-oh, I did something. Think function, update function, free function. And I need to take return void and take a pointer to itself. So let's forward declare a couple things. Void player think, void player update, void player free. Now, I don't necessarily have to declare these. I do check to see if they're null before I call them. So if I don't have to think as a player or update as a player or free as a player, I don't have to. And right now, I probably don't have anything special to free, as this is going to be a very bare bones example of what a player would look like. But now let's start identifying what the player should look like. All right, so first we need an entity. So entity star, we need a pointer for the entity, self. And at the end of this, we're going to return self, because this is a function that has a return type. We're going to set self equal to entity new. And because we don't trust our pointers, we're going to check to see if not self, then slog the error, failed to spawn a player entity. Return null. This function has a return type, so we're returning null on error here. Oh, in which case I should mention in my header file at brief spawn a player. At return null on error or a pointer to the player otherwise. Neat. All right. Next, let's give us some data. So what's the rest of this stuff? We have a sprite, we have a frame, and we have a position. A super complicated entity here. Small beginnings for big things. We're going to set our sprite. Self sprite is going to equal, what is it going to equal? We're going to have to load a sprite. So let's take a look at what sprite we're going to load. First, let's see what the sprite load function looks like. I've got this one, sprite load all, since I want to have an animated sprite. I use the same sprite system for both flat images which doesn't take any parameters. It defaults all this out to make it work with a flat image or for sprite sheets. I'm going to do a sprite sheet version here. And keep surface is, the more on this in the future as I start taking a closer look at the SDL rendering pipeline. But there is a software version of the image that we load off of disk, and then there is a hardware version of it when we save it as a texture on the GPU. The rendering engine for SDL does most of its stuff through the GPU. Now that's optional, but that's an option I have turned on. So during the process of loading the image off of the disk, I convert it to a texture. Now, if I'm only ever going to draw with it, I can keep it in the GPU and leave it there, fine. But if I ever want to do any additional analysis on it, like I want to do some pixel level collision detection, I need that in the CPU so I can do that work there. So this Boolean for keep surface is whether or not I want to keep the software copy in memory. I don't need it right now, so I'm going to leave that as 0. How many frames per line? Oh, well, to answer these questions, we need to know what file we plan on loading. So let me go and look at what I have available in Git, Game Framework 2D, images, and I gave us some stuff to work with. So if you want to follow along, I'm going to grab the ED210. Now I'm going to grab a space. No, ED210. Let's be a robot. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 frames across. So that's how many frames per line we have in this image. So that's going to be 16. The name of the file is ed210, and it's in the images folder. So we can give this a constant string here. So this is images ed210.png. How wide is our frames? I'd have to guess. Let's take a look at the file properties here. If you knew ahead of time, this would be easier. But the image information, it is 2048 pixels wide. So 2048 divided by 16, and the width is 128. And I do remember I made this as a square, so it's 128 by 128. It's a large sprite. So 128 is my frame width, and 128 is my frame height. And now I should be able to load this image, the frame. Well, let's leave it at frame 0 for now. So we're going to set self frame equals 0, and the position is going to be vector 2D 0, 0. To begin with, let's just see if we can get it on the screen, and I'll worry about making behaviors. We're going to set our self think equal player think. And again, we're not calling the function, we're assigning the function. And the same thing for update and free. And now we need to actually define these functions so that they're called. They have something to call, even if they're going to be empty. Right now, it's probably going to be empty. The player is not going to think. The player is not going to update. It is just going to be. And the boilerplate code, if not self free or return. Oh, and these all need to take a entity self. So if you've been watching along and screaming at the video, hey, you forgot to parameter. I did. Now it's here. Dupe, dupe, dupe. All right, so just doing all the needful, even though we're not doing anything yet. All right, let's make sure that the code is kosher. And now that that's there, we will need to spawn the player. So I'm going to go over to game.c. We're going to now include player.c. Or put that H. And then sometime in my setup, I'm now going to make an entity pointer to keep track of it. I don't need to. I don't have to catch it. The system will automatically maintain it and clean it up when the system is done. And now I'm going to set here player equals player new. And just to be extra clean, if we clean up, we're going to entity free the player. I don't actually have to explicitly call player draw since it'll always be drawn in the system. Let's see, make, and nothing's there. Nothing is there. Oh, look. Ooh. Cannot have two instances of an entity manager. One is already active. I have a typo somewhere. And this is why debugging is handy. Failed to spawn a player entity. No more entities available. Cannot have two instances of... Oh, I had it before. Okay, so it looks like my entity manager did not actually spawn correctly. I have a feeling I asked the question backwards. And again, if you've been following along and noticed, here is now where you get vindicated. Cannot have two instances if not entity list. No, if entity list. If we already have one, that's the problem. Can't tell you how many times that's my issue. Hey, look at that. I have a little spaceship right there. All right. Now, let's give it some behavior. And we're going to keep this behavior very, very simple. For one, let's animate our frame. I don't know how many frames line up to any specific thing, but let's say the first, let's do the first 16. Let's just animate through the first 16 frames of animation and see what that looks like. So in my update function, what I would do is I'm going to do self frame plus equal 0.1, because doing whole integers is, you'll see, very, very fast. And then we're going to do self if self frame is greater than or equal to 16, then self frame equal 0. We're just going to iterate through the whole thing like that. Make, run it. And look at that. Now a little robot there, spaceship, is stretching. Still not moving, but it's animated. Because over here in our draw function, we draw if we have a sprite based on our current frame. So we're already doing all this fun stuff. We're just now using this code base. Now let us think. Let's take a look at the player and think. I want to have the player just move toward the mouse. So for that, I'm going to need to get the mouse position in the screen. So that's going to require me to make a uint 32 mx my. And I can initialize these to 0. Oh, that's unnecessary. And I want to do SDL get mouse state. Now this was used to in our main game loop earlier. Actually, yeah, I just want that code. Thank you. And I want to get the mouse positions on the screen. Now I'm going to compare this to my entity position. So if my self position dot x is less than mx, and then I want to, I need to give myself some direction. So what I want to do here, I'm going to make a dir, vector 2D dir equals 0. It's a little 0 vector there. I'm also going to go into my entity header file here and add another vector, vector 2D velocity. This is going to be how much an entity's position changes per update. All right, so if my position is less than the mouse's position, I'm going to set my dir.x equal -1. And I'm going to ask the same question about the y. And the same thing in the other direction. So if my position is greater than, then I'm going to set it equal to +1. I'm now going to vector 2D normalize. No, it's not capital. My functions are vector 2D normalize. There it is. Let's take a look at what that actually involves. Normalize. It takes a pointer because we're modifying it. All right. So I'm going to give it the address for dir. So now I have got a normalized vector, and now I'm going to vector 2D scale. And let's take a look at what vector scale does. Vector scale, it sets the destination equal to the source times the factor. So I want to save into my velocity my direction times some speed factor. I'll set it to 3. Why? I don't know, pulling a number out of the ether just to test. And that's what I think is going to do. Now my update is going to vector 2D add. And if I remember correctly, add sets destination equal to a plus b. So we're going to take my position, self position, and we're going to base this on position and then velocity. Make. Oh, there's bugs. Oh goody, oh goody, oh goody. Pointer targets differ in signage. All right, I gave it unsigned 32-bit integers. What did it want? Oh, it just wants regular integers, which probably just means signed 16-bit or something like that. So I'll go back to here and just go signed. And now entity has no member. Okay, typo. What line is that typo on? 57. Oh, someone should have said something. Oh wait, it's a video. All right. Nope, something's wrong. Oh right, if I'm less than, I have the signs backwards. That's why we test. All right, that kind of works. And that kind of has behavior. It's not beautiful, but it works. It's animated, it's got behavior. And that is the basics of what a entity system is going to look like. As we develop this further, we're going to add a lot more features to it, and they're going to be specific to your game. So I'm going to try over the next couple weeks, once I've finished going through the basic setups, to give you some examples of what things can look like. So just to give you some guidance, some ideas, some design patterns to draw on, some more tools to your toolbox. But a lot of this is going to be you looking at your design and thinking about, all right, what features do I need in order for my entities to do X, where X in this case is whatever it is your game needs it to do. We're going to have another video later on the world itself. If I have time, I might today, if not soon. I know it's fortunately, by having everything moving by 3, it never quite lines up. Anyway, let me close that. And so ends this video. Keep following along, start developing your own entity systems. If you know what kind of game you're going to do, like if it's a top-down, side view, 3/4 view, whatever kind of view game you're going to set up, start working on your entity system. Start putting in the variables you think you're going to need for your entity system. I just gave you here the minimum viable entity system with a minimal viable entity here. It's not even really an entity. It doesn't even really respond to input. Well, I guess it moves toward the mouse, which I guess could be like a targeting reticle, but There's not a lot of behavior here yet. But start thinking about it, start building whatever it is you need for your game. And then once you have some kind of entity system showing, what I'd like you to do for your exercise is show me what your entity system does. And I don't want to see just a copy of my code here. I want you to put something into there that makes it a little bit more robust than this example. And we can talk about it in the Discord if you need some help and direction. But I want to see something done, unique, and by you. At the very least this, but more than this. All right. Hopefully this is helpful.